My name is Wandu. I'm an associate professor in the Department of Computer Science and Engineering. We want to save as much water as we can. Saving water, I think first it will reduce the cost of the growers. One of the most important things is that we can save the natural resource for our next generation. And at the same time, we want to improve the production of the field. It is very important in Central Valley because drought is a very big problem in this local area. 3 professors from UC Merced and several graduate students. We are working with Khaled and in this farm to implement our smart irrigation system. As you see, this is our valve and the pipe for the irrigation system. And we have sprinklers almost under every tree, so we can control here to make sure that we start the sprinkler and close the sprinkler remotely as we want. And to make the decision, we have developed some machine learning algorithms that can process the data and then make the right decision to open the sprinkler and determine how long we open the sprinkler.
So this project is working on AI irrigation scheduling. So we will use deep reinforcement learning by feeding irrigation data for this almond orchard into an algorithm, which will then give us future irrigation recommendations. And as it does this, it should become more and more accurate.
Dr. Do has a project here in collaboration with our scientists from here in Kearney, and Dr. Do and Dr. Khaled Bali. They are doing really amazing research using artificial intelligence to help the growers when and how much to irrigate. That's going to be very helpful for growers to manage their crops in a timely manner.
Some of the data we're seeing here is a data logger for soil moisture. So attached to this are 8 sensors that all measure the potential for water to move through the soil. So this is then transmitted to this box, which then uploads the data to the internet. So it's accessible by the algorithm. Over here, we have stem water potential measurement. So this measures the movement of water through the tree and measures the potential for it to move through the tree. So it will show if the tree is water stressed or not. So by using this, we're able to track the water movement through the irrigation system, into the soil, the uptake by the tree, and eventually out through the leaves.
If you ask the tree will just tell you, I am stressed or not. It doesn't tell you how much water to add. So you have 2 different types of sensors. The sensor on the tree will tell you if there is a stress or not. The sensor in the soil will tell you what's the level of the moisture. And so the soil, definitely you need a soil sensor for irrigation scheduling.
This is a test bed. We want to test how much water that our AI model can save. So we need to have 2 sets of fields. One field, we use the traditional method to do the irrigation. Another field, we use our AI model to make the decision. So finally, we will compare that how much water each test bed will use and what is production and the result of these 2 fields. We are verifying our model by using simulations and some historical data. And another thing is that we want to make this test bed totally automatic, so we can control the valve of the sprinkler and read the data all remotely. So we can sit in our lab and control everything in the farm, and also verify whether our operations is correct or not. So we will also have a camera to monitor this area. And after we verify everything in the lab, we will deploy the system here and do the test. We hopefully we will start the real experiment in March when the trees start growing.